Bon locale to anyone out there in the audience. Hello, 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 and welcome to my new programming stream. Very glad to be here. I'm very glad to see you all here. It's kind of nerve-wracking setting up a new stream. Good lord, my hair looks like shit. I'm sorry, guys. My hair looks like shit, so I'm going to quickly switch back over to the cover scene, grab my brush, fix my fucking hair, and talk to you guys for a little bit about what's going on while people show up to the stream. So yeah, what we've got going on here essentially is something new, right? So previously I had been, let me take the oops off the screen for a minute. Previously I had been working with JavaScript when I was showing you guys these things. And JavaScript's a very important language these days. JavaScript is basically the language of the application-based web. JavaScript is going to be used for basically everything and variations of JavaScript as well. However, it can't be used for absolutely everything. For example, you don't want to use it for hard, low-level code. And unfortunately, when it comes to making a blockchain system and server, or well, node, I should say, we need to reduce the amount of cycles as dramatically as possible, right? We need to be doing things at the byte level and the memory level in a lot of cases so that this thing moves quickly and can operate without interfering with the rest of the system. What system am I talking about? Well, of course, I'm talking about this blockchain system that I've been designing for the last month, in which you can essentially create private blockchains for yourself, personal blockchains for yourself, that sync up between your own computer, your phone, your laptop, a Raspberry Pi if you like, any of these things, you know, and basically have an in-house network of nodes that are keeping all the data together. Why would you want something like this? Well, the reason a lot of people are going for right now is medical purposes. Medical data needs to remain immutable. Now, immutable, of course, is data that cannot be changed once it's set. And this is a very important concept when it comes to programming. Yeah, I'm not getting many viewers. This is sad. That's alright. We will go. I will probably do something about that later. Actually, let me link this shit out again to a couple places. Actually, I guess I really don't have anywhere else to link it. I've already linked it on all the socials. So, let's just quickly go over to Twitter. As much as I hate Twitter. So, we need a stronger language, is what we need. We need something that can be used more specifically for systems that can still provide us with a back-end that we can place a front-end on. I ended up choosing to use Rust because while I've got a lot of experience with C and C++, it's... I have a thing about new languages. I love new programming languages. I love diving into new programming languages. I love being on that bleeding edge. And Rust provides something that almost no other language provides, and that's a pure form, a semi-pure form of functionality with a presentation or coding style that is very similar to C. Why I didn't use Go is because I refused to use Google's code base. I will fork their code base, I will make modifications, but when it comes to a programming language, I'm not using Go. So I'm using Rust. And today we're actually going to sit down, we're going to spend some time making a web server in Rust so that you guys can see exactly what this language is all about, because it's so much more complex than JavaScript is. JavaScript is very direct. It's interpreted. It's not, saying it's not typed is not completely accurate. Every language has types. It's just a matter of how those types are treated, whether they're scalars or whether there are a minimal amount of base types that are transparently interchangeable, or whether those types are hard and you have to produce your own code in order to convert between types. And Rust is, of course, a strongly typed language. It has generics, which are a very effective replacement for templates in C++, and for the concept of duck typing. Now, you can't actually duck type in a generic language. You have to, in Rust specifically, you have to use traits. In template languages, you have to use abstract classes. But nonetheless, we can create a system that can interact with any type of blockchain data we want. So if I'm talking so much about blockchains, why am I making a web server today, you might be asking yourself. Well, one, it's a great place to start. Much like the idea of a Hello World application, which loads up, prints Hello World, and then quits. The web server is a functional solution that can be created quickly and simply, and you can interact with it very directly with great ease. In fact, we're also going to be using a tool called Postman today in order to explore that data. Excuse me. The data, which will be extremely simple, mind you, but provided nonetheless. Where's my chat window? Hello, Martin Krishik. And, you know, your opinions are fine, but the fact of the matter is, languages have all different purposes, and if you don't like it, you don't have to use it. Although, based on your attitude, I find it safe to say you probably like basic, because you seem like quite the basic bitch. But back to the stream, let us hop onto the desktop so that people can bitch about the fact I'm also using Windows. And let's get started. Clear. Now, Rust is pretty direct. It provides a lot of its own toolchain, so we don't have to go out and build our toolchain like we were with JavaScript and Babel. So we can literally just cargo new web server bin. This creates for us a web server directory, which has a couple files in it. A cargo.toml, which instructs Rust on how to run its basic build commands. We'll also eventually be using an application called Just, which is kind of like make, but for Rust specifically. And we also got a source directory. Fucking typos. And in that, we've got a main.rs. Now, Rust, being a compiled language, usually requires you to follow some sort of standard entry point, and unlike C, your entry point has to be a file named main with a function named main, as compared to just having a main function somewhere in your application. The main function has to be declared in main.rs. So let's open that up right quick. Main.rs. Yeah, Ada is pretty hardcore, honestly. I do enjoy Ada, however, I'm not programming for the government, so I don't see a reason to be using it personally. Oh shit, you're right. I don't have my usual mods on this channel. let us mod up Cajo and Arakeen and get rolling. Oh, not main.rs, source main.rs. And of course, when you create an application in with Cargo, it immediately just gives you the a Hello World application, but we don't need that. We don't need that at all. What we need to do is start making a web server. Now, what exactly is a web server? Simply, you know, in its most basic form, a web server is an application that takes a TCP request or a transfer control TCP. Transmission control. Transmission control protocol requests, or to put it simply, a request that comes in an orderly fashion as compared to, and this is a very, very undetailed manner of describing it, but for people who don't know a lot about network protocols, the easiest way to think about TCP is it is the way that data is transferred from your IP to another IP in an ordered manner. It takes that request, it parses the request, sees what's being requested for, and then returns a header and a body in which the body provides data, usually HTML or text, but honestly it can provide anything from the server to the client. It's a very straightforward system of, you know, send a message requesting information, and then the server says, okay, I can handle that request, I have that information, and because the route is open between the two systems, it then sends it, and it then sends its response, which is a bit of, you know, whatever the data requested was. And we're going to start very simple. We're going to start with a very basic single-threaded server and grow it slowly as we're programming. Is that are my pop-ups showing up? Damn it, turn on quiet hours. Sorry about that. Sorry about the pop-ups that are coming up. Popping up down here. You can't see my mouse when it's over my... That's weird. Whatever. Anyway, so we're going to start very simple. We've got our little application set up, and I'm actually working from the Rust programming language book because it's an amazing book. But we're not starting at the beginning because I'm not going to sit here and bore you with the fine nitty-gritty details of language features and data types, etc. Instead, we're going to dive headfirst in and discuss them as we're using them so that you have a better idea of what's actually going on with the language. Because while, yes, it's a curly brace language, as many people will complain about, it's also a really fascinating language in its design and execution. It's something I love, something I've fallen in love with time. But yeah, so the very simplest a very simple web server would be just a few lines of code. Use standard net TCP listener, and of course this will provide us with an actual system that will allow us to connect to a port and listen on that port for a single request. Now, this will be single-threaded. It's not going to be super impressive yet. It can only handle one request at a time, but it's a place to start. And we're just going to get a little code written here. And save. Now, when we compile this with cargo builds, we are going to get a warning, for one. It's going to tell us that we have an unused variable. we set let stream equals stream unwrap here, but we don't actually use it yet. But that's all right. You can have warnings in this system with this system, or you can actually disable warnings if you want to. So now I'm going to show you it running with cargo run, and of course, it's not going to be doing terribly much, honestly. What we're going to do is pop open Postman, which is a very simple system for sending requests to a server, usually HTTP requests and the like. Great little tool for just, you know, crafting your requests to servers and seeing how they respond. I do not want you showing that request on startup. Oh, go away, thank you. And we are going to make a request from localhost 7777, because that's the port that I set it on. And send. It says we couldn't get any response. However, over here, it's now responded connection established, as we told it to do. It isn't responding, however, the server is taking requests. Now, this isn't a web server, per se. This is literally just a socket opened. Now let's actually walk through the code and see what's going on here, right? So first we use standard.net TCP listener. Now this use statement basically tells Rust to reference code from another crate, as they're called in the language, a library, called standard.net TCP listener, in which you can find a basic socket code library that can be used to listen on a specific port for a TCP request, and then you can gather all of the information available. Or rather, you can gather information from the request. Once the connection is established, of course, there is actually a pipe open between the server and the client, and once you've connected, I'll walk through the code. When we run cargo run, it calls function main. FN stands for function, and then we create a variable. Let assigns a variable, and because this is a functional language, by default, every variable you create with let is going to be immutable. It can't be changed once it's set, unless, of course, you add in the mute function. So that means mutable. This variable can be changed after it has been set, but we're not doing that. And then we're assigning it to a TCP listener bind, which returns a new TCP listener. That would be very similar to using like TCP listener new. And if you've been watching my JavaScript streams on my other channel before I split off over here, new creates a new instance of an object. Now, Rust isn't actually an object-oriented language. It uses generics, structs, and implementations. So essentially, while we are creating a new object, that object is merely data that has functions that can be called on that data, rather than a full-fledged object which inherits down an object tree to a base object. It just inherits directly, it just derives directly from a structure, and we'll get more into that as we're moving forward. However, we are binding, and bind is essentially like new, except it also takes an IP and port and creates a listener on that port, opens that port to have connections be made to it, and then we unwrap it. Now, unwrap is actually quite interesting because what we're doing, unwrap will look if we have an error. So TCP listener bind doesn't return a TCP listener per se. What it returns is a result of type T and E. What are those? Well, this is when we get into generics. Rust has quite a lot of generics. Let me grab a reference here just to read this off for you. every programming language has tools to deal effectively with duplication of concepts. In Rust, one of those tools is generics. Generics are abstract stand-ins for concrete types and other properties. When we're writing or compiling code that we can express properties of generics, such as their behavior or how they relate to other generics, without needing to know what they will actually be in their place. Now to unwrap? No. Yeah, okay, so these generics, or rather the generics we're using, use a type or a struct called request, which has two generic types in it. Type T, which represents a result of, which means it can be a result of basically any type that matches within the traits provided. And as far as I know, there are a ton of traits supported by result, as well as E. So let me give you so this returns a result TE, and inside these angle brackets we have type T and E. If E is provided, that means we've been provided an error. And since we don't want to handle the error ourselves right now, we just want to die out if it can't connect to that port, what we do is we unwrap it so that we only get the T portion of the results. And if we have an E, unwrap will just end our program. It will just shut down. So now we have a listener. We have a listener bound to port 7777 on localhost, and we need to use it. So for stream in listener.incoming. Incoming is a function that takes the next or the most, not the most recent, the well, first in, first out, right? So it takes a list of requests and then grabs the first request. And then we use that here. We're actually re-unwrapping the specific stream into something we're going to see in a moment, a standard net stream, a TCP stream. But we're not doing anything with it yet. We're just assuring that we have a connection open, a stream between the client and the server, and then we're printing down here that the connection is established. Now there's a lot more details to this, and I absolutely recommend you read the Rustlang book when you get the chance. There's a lot of difficult concepts in it, but when it gets down to it, it's very simple. And that's one of the reasons I love Rust so much. It's a very effective language for producing great things in a very small amount of code. And part of that is due to its functional nature. I'm sorry, my throat is killing me this morning. So, because we can't change anything, all of the underlying code here is very, very much without side effects. We don't have to check on this or that. We can just assure, okay, we know that we've got our request, the system knows it got its request, or rather, it got its port, and was able to open it up. We can unwrap and provide the actual result data, the T, to our listener and assign the listener to that data. Now that we have it, we start waiting for requests, and when we get a request, listener.incoming, we're then going to assign the stream to that data that is provided to us from the listener.incoming, which gives us back a stream, and we can unwrap it so we can use that stream, assure that the connection's actually there and not just an error. And once we have it, we say that we're connected. Now, this is great and all, but it doesn't actually do anything. And places where bind would fail, bind would fail, and therefore unwrap would send an error and end the program. would be cases like trying to attach to port 80 when we're not an administrator. Let me show you that. Now, I don't actually have to run cargo build every time. It will automatically build for me. And here's what happens when we try to assign to port 80 instead of something above 1024. Thread main panicked at called result unwrap on an error value. Value error rep R, I'm not sure what that stands for, 0 seconds. Code 13 message permission denied. We're not an administrator, so we can't bind to port 80. And then it tells us that this is from checkout source libcore result.rs. Now, where is this code actually at? Well, it's not our code, so we don't have to worry terribly much. But we can always get a full backtrace to see what's going on. Oh, gotta set that before that. And there we go. We get a full backtrace of everything that went wrong. So, we get our error, thread main panicked, right here. And then we see that we have a couple lines of the actual backtrace code running. And then from there, the panicking code running. And that's when we get to our actual error. Here. This is the error it's telling us about, but the error is actually occurring for us at webserver main at source main rs.5. That's this line right here. Now we can actually see that what they're doing is a little bit more. In order to check on our generic shut up phone. God, I charged my phone for the first time in months, and all it wants to do is beep at me. So what we see is going on here is, here's where we're calling our stuff, right? This is exactly where we called tcplistener.bind, and we can see that it is trying to... But there's actually technically a test wrapper around all of this. Try do call. It's attempting to call something on our results, but what we're realizing is that, what the code is realizing is that it's actually an error. So we end up with a failed unwrap, and because it's a failed unwrapped, we panic. Well, panic sounds really stressful, right? However, it's not nearly as stressful as it sounds. It's literally just the system doesn't know what to do, so it's going to quit. Let's let this thing do a little bit more, shall we? Let's fix this so it is 7777 again. And let's add in a little more functionality. Use standard net... Oh no, wait. Standard IO prelude star. This includes all of the prelude code. Every one of the classes under prelude. I say classes. And every one of the libraries under prelude. And there are quite a lot of them. We need these in order to bring traits into scope that allow us to read from and write to the stream. Instead of just printing our message here, we're instead going to be passing stream to a function called handle connection stream. Now, we don't have a function called handle connection stream yet, so let's create it. Function handle connection, which takes a mutable stream, which is of type TCP stream. It doesn't have a return value, so we're not actually going to put a return value in there. We're going to create a mutable buffer. And this, what we have right here, this little bit of, this thing right here, Kind of looks weird, I know. Essentially what we're doing is we're creating an array indexed at 0 that can hold 512 bytes in length. We're going to basically be taking the header, and that's all the request header, and that's all we really need. It's rare, except for basic requests at least. If you're just requesting like an HTML page, you're not going to have a huge header. It's not going to be that big. So you only need about 512 bytes. You probably could use less, like 256 if you want to. But let's stream.read mute buffer. What we're doing here is unwrap. Let me actually give you a better explanation of unwrap right quick. There's actually a really decent explanation of it right here. In Rust, when you have an operation that may either return a T or fail, a T being a type, you will have a value of type result TE or option T, where E is the error condition in the case of an error. The function unwrap will give you the embedded T if there is one. It'll essentially give you, as I was explaining before, it will give you this, the result of this, if there is a result and not an error. Now we're doing the exact same thing here, except we're not assigning it to anything. I mean, why aren't we assigning it to anything? Well, we don't actually need to do anything with that data, right? What's going on here is the stream is taking this buffer and saying you're allowed to change it. We're referencing a mutable buffer. We're telling the read function that the buffer is mutable and that this is a reference to the buffer from here. We're passing this buffer into the stream's read function, and then we're basically error checking right here. We're assuring that this returns a proper result and not an error. We're not doing anything with that result, but it's good to do that error checking nonetheless, so that we just panic out in the event something goes wrong. And now we're going to println requests string from UTF-8 lossy buffer. Alright, so now this is actually kind of a weird line. Again, we're using println to print to our console when we do. And you might be wondering why there's an exclamation point. In some functional programming languages, there's actually this impromptu standard. Ruby does it as well. If you have a function that is mutating data, or operating with side effects, you want an exclamation point. I'm sorry, someone's at the door. Just 1 second. Sorry about that. Let me get back to the desktop. No. Desktop for you. So what is going on here is, you know, we are mutating data. We are printing out to a stream. We want to print the words request, and then we have this weird little double curly brace right here. In Rust, instead of telling your string what the data type is, you basically are just going to be giving it these little curly brace pairs in order to say, I need you to take the next thing from your function call and print that in this spot. And what we're trying to print is a string from UTF-8 lossy. And that is a reference to our buffer, which takes all fields. every one of the bytes is going to be converted to UTF-8 and returned as a string. And again, a string is just a string of text. So let's actually see what this does. Don't really care whether it backtraces or not. What? Why? Unused import standard IO prelude. Liar. Oh, I'm an idiot. I forgot to add one thing. I'm an idiot. I'm sorry. I completely skipped over a line. Use standard net TCP stream. Save. I don't know how I missed that. There we go. Now it's running, and we can make a little postman request again. And it's still saying we could not get any response because, well, we're not making any we're not providing any response yet. However, now we get this interesting output right here. This is all of the code. This is all of the code, or excuse me, all of the request header that was provided on this line, here. When we made our request, when we sent a request to localhost port 7777, we unwrapped the connection, we passed that stream down to here, we created a buffer, we read the data from the buffer, which changes the value of buffer, which is why it's mutable, and then we unwrap it. And when we unwrap it, what we get is a pretty standard HTTP header, right? So, well, somewhat standard. This line is very unstandard. This is very specific to the tool we're using. Alright, so, what we got here is this is the heart of an HTTP request. If you're making an HTTP request to a server, this line here, request get / HTTP/1.1, tells your server, hey, I need to speak to you using the language of HTTP version 1.1. I am trying to get the file that is provided at / or the root directory. So, with our example here, you can imagine what we've got is actually HTTP localhost and a / at the end. Now, your average web server has settings in place that will make this load up index.html, but for something as simple as this, we don't even have an index.html. We are just requesting the root data, whatever is at the root. And that is what we are requesting here. Next we have cache control, no cache. That's so in case this server is able to cache data, we end up responding by saying, don't cache this. I do not want cached data, I need the freshest data. We then have a Postman token, which allows us to identify which instance of Postman is running. We have our user agent, which tells us the browser that is making this request, in which case, in this case, we're actually using Postman Runtime version 7. But if we did this with Firefox, for example, we get user agent Mozilla 5.0 running on Windows NT 10, Win64, R64, revision 59, with the Gecko engine, Firefox 59. Now that is a very long user agent, and that's because versions of browsers have broken compatibility with different kinds of things. And for the most part, you just really want to be sure you've got a browser, your system has, or rather, your application can support the browser. So that's where we get this data. Now, it repeated itself 1,000 times because it really, really, really wants to make sure it's not able to get the data. Browsers are abusive. The next line we have is accept. Now, accept */ means we can accept any type of data. It can be text HTML, application HTML plus XML, application XML, text plain, octet stream. There are a number of MIME types far more than within the scope of describing what I'm doing now. But then we have our host, which is saying where the request we're trying to make. This is the name server we're trying to use and the port. This allows certain web servers to say, oh, you're making a request for blah blah.website.com. All right, I'm going to forward that to the virtual host within my code. But in this case, we're just using localhost, so that's not important. Accept encoding tells us that we can it will allow us to send compressed data, and then it will or it can send us deflated data. And then connection keep alive, this is the other part where I was explaining that once we create the stream, there's an open connection between the two computers. It's this line here that keeps the connection alive until the response is received. And if it doesn't receive 2 carriage returns, 2 ends of line in a row, it's going to remain alive and you can keep sending data. This is actually how Twitter runs, or at least it did up until a few years ago. You could, when you connected to Twitter, the web page just stayed open, and they would pipe more information down that stream, which would be collected by the web page application itself, and then you would get a notification on your browser tab saying, oh, you've got new tweets, click this button. And Keep Alive is used for a lot of things, but it's also extremely inefficient. It's also unidirectional. You can only receive via Keep Alive. Once you make a request, that is. But yeah, now we've got a very, very basic web server. Or it's not even, I can't even really describe it as a web server yet. But what we've got here is standard prelude, which includes all of the traits. Remember I mentioned traits at the beginning of the stream? Traits are the system by which generics are able to function. You're able to check on different traits with a generic function and determine whether or not this trait provides a specific function within it to the data or to the structure that's being used. Martin Krishik says, interesting way of error handling. It's not actually, that's not the entire error handling system. If anything, using unwrap here is a bit cheap. It's a very inexpensive way to just panic. It would be like using fail or die in like if if error then die in other systems. Perl being a language I'm very familiar with, fail and die are the first 2 that come to mind. But again, this doesn't really do much for us. We're still just, we're still just receiving a request and not sending anything back. So what does, if a request looks like this, what does a response look like? Well, a response looks kind of like this. Bah, stupid new keyboard. This keyboard I'm using is a pain in the ass. Yeah, so this right here is all we have to do to respond. We say that we're speaking HTTP 1.1. We give it a 200. Now, if you know about response codes in HTTP, 200 means OK. And that's why it says 200 OK right here. And then we give it 2 carriage returns, 2 empty lines in a row to say, this is all we're sending you. This is the end of what we're sending you. Now, how do we do that for our stream? Well, instead of print lining here, we're going to let response equal HTTP 1.1 200 OK RN. And then we are going to stream.write response.as bytes. We need to send the data back in byte format as compared to just sending the text directly. And then we're going to unwrap again just to make sure our connection is still there. And then of course we've, written, but the data isn't actually going to go to the other user yet. We still have to stream.flush and again unwrap to make sure that we've actually flushed and not returned an error. So now what happens when we do this? Come on. There we go. Send. We did not get a body, but you know what? We didn't even get a header, but it did respond. We're getting something very different here. No. Oh, well, I guess it shows it up here. Here's our 200 OK. It took 523 milliseconds, and and the size of the data was 17 bytes. 17 bytes, you might ask. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then each of these carriage returns is 1 byte as well. So that's a total of 17 bytes. Shit, where's my tab? Alright, so now we're actually responding. But what if we actually want to, return an HTML page? Well, that's actually quite simple as well. We're going to start by adding in a code. Code hello.html. And we're just going to create a very simple doc type HTML. HTML lang equals n. Head meta char set equals UTF-8. Title hello world. Body header 1 hello world. P this was shot back at you by Rust, and save it. And then we need to make some changes to our actual server code. So we're going to start by using standard.fs file. This is going to allow us to interact with files. We have to in order to actually read this hello.html. And then what we're going to do is actually let mutable file equal file open hello.html, and of course we're unwrapping. Let mutable contents equal string new file.read to string mute contents unwrap. And now we send in we give it a body format. Contents. Alright, so now we're basically doing the same thing we were before, but now we've added in this code in order to read the contents of hello.html. That's right here. Or rather, we open it first. We create a connection to the file to read its data. We create a string to put its contents in. And then we read to string. We take file, and then we read from the file, outputting a string into mute.contents. And then we unwrap it. Even though we're not assigning the data, we're making sure that an error isn't occurring, and just dying if it does. Of course, when we get to writing actual, production code, you'll see a lot fewer unwraps. Unwraps will be used, say, in assignments, but you're going to be basically using a lot more try, do, call functions of your own to capture your own errors and handle them yourself instead of just letting the application die. But, I mean, we're just going with an example here to show you how this code works. So, let's make sure this works. Nope. We already have code.hello running. Alright, it compiles. We send our request again, and now it has taken the contents of hello.html, and it has returned an entire header, 2 carriage returns to tell it that the body is started, and then the contents of our request. And if we do this in the browser, we get this. Very simple, very painless, but it's actually doing something now. It's actually behaving as a web server. We are making progress. Now, right now, the web server will only ever return hello.html, no matter what we request. Goodbye.html still sends us hello. So how do we deal with that? How do we make it allow us to request other things? Well, that takes a little bit more modification to our handle response. We want it to return an error if we are if we request anything other than the root, right? So let get equal bytes for get http 1.1 rn and make a test. If buffer.starts with get and just indent, no, undo. Come on. There. Alright, so, and else, we are gonna have to fail out here. So, now, when we get a request, if we are requesting the root of the web server, it's going to return hello.html, or at least the contents of hello.html. And of course, we give it a 200 OK. Now, what if it doesn't start with that? Well, we need to throw an error. So, let status line equal http 1.1 404 not found r n r. Damn it. Have a good day. R goddamn keyboard. So the backslash key on this keyboard is actually in a really irritating position. I'm used to it being above the enter key, but my enter key is a solid vertical block that takes up 2 lines, and the slash is moved to the place where the thin elbow of enter usually is. So I keep accidentally hitting the quote, and my key bindings are set for US International. So I have to, if I hit, you can hear me hitting it, I have to hit it twice and it will print out 2, but that allows me to also do things like that and get special characters, but that's beside the point. Let mutable file equal file, open 404.html, and unwrap it, return the data or die if we get an error, and then the contents read to string mute contents dot unwrap. We're doing the exact same thing we were doing above, only this time it's a 404 error. let response equals formats. And we're using 2 bits of data here, but this is going to be status line and contents. And stream.write response.as bytes. Unwrap. And stream.flush. Now, kill this off and try again. Wait, what? Liar. Oh, shit. Contents isn't mutable. That's my fault. Alright, so now we should have a running server, and if we request goodbye.html, we get a huge fucking error because we don't have a 404 page. HTML, lang equals n, meta, char set equals UTF-8, and yes, I do use XML style tag endings. Title 404 404'd. Oh shit, I forgot head. Body H1 404'd, and we just save that. It doesn't need to be detailed. Nope, it's already open. Now we run that again, and instead of being an idiot and not having the file necessary, we send, and we get our 404 data. Can I increase the font size? Please let me increase the font size. I need to zoom in a number of times, don't I? So, we've got our 404 data here, and if we do this with a web browser, we get the same results. Localhost port 7777, goodbye. And we get our 404. But if we make a request back on the root, we get our hello world again. Perfect. No. I'm not done with that. Pages are being a bit weird. So now, we have our code, but this isn't very clean. Essentially, all we can do is request the root or throw an error at the 404. So instead, what we're going to do, we're going to clean this up a bit. We're going to refactor it and make it run just a little bit cleaner, alright? So we're going to we're going to use a feature of Rust that is very straightforward. You can actually use let as for conditionals. So let status line equal, oh wait, no, I'm sorry. Let status line file name equals if buffer dot starts with get. Shit, I need to take get from somewhere else. There's, my apologies, I am looking for where I... Oh, shit, I should not have done that. Okay. There. And now we come right under this, let status line file name equals if buffer dot starts with get. We are going to We are going to be returning HTTP 1.1 blah 200 OK rn as well as hello.html. Now what this is here in these parentheses, this is just a tuple. We can send two bits of data collected together, and they can't be changed. We can be assured that they're in order, and we know that the data returned by this is going to be a status line and a file name. Now, if we don't get this get line, we need to else return a different tuple, HTTP 1.1 404 not found see, I keep missing that key. rn as well as 404.html. And now let is defined by what the request is. Is our request root or not? And from there we can literally get rid of half of this shit. We can get rid of all of this. 7 lines need to be unindented. File.open, and instead of sending in this here, we then just say file name. And status line stays the same, everything else stays the same. I believe this will run. Did I miss a semicolon somewhere? Yes, I did. Okay. Unlike other languages, if statements, especially when they're used as part of a larger definition statement, need a semicolon at the ends. Let's try that again. Cannot borrow immutable local variable contents as mutable. Why didn't I set that to mutable? I could have sworn I did, but whatever. There we go. Now it's running again. And if we send our requests, we get our hello world. And if we go to something that doesn't exist, like goodbye, we get our 404 page. This is the very simplest single-threaded web server that you can create. It is a total of 33 lines, 34 including the carriage return at the end for readability's sake. And most of the work is going on inside a function called handle connection. The connection is made, we make a connection, right now we're using a browser or Postman. And this application receives the request on the listener and then passes the stream in. We unwrap the stream into itself, essentially, and then we pass the stream to our handle connection function. We then check the header of our requests, which is and if it says get HTTP 1.1, we pass it the hello.html and a successful header. And if it is not root, we pass it an error header and our error page. We then open the file associated with what we wanted to return, convert the contents into a string to be used by the code, and then produce our response and push it down the stream. Also, that semicolon there was bugging me. And that is the start. Now, I have a lot of these streams to do, because that was just a basic single-threaded stream. I can't make 2 requests at once. It can only do one thing at a time. That's a problem. That's a huge problem. Because, let's face it, the internet does not operate like that. You need to be handling thousands of requests a second, possibly. And especially with our blockchain product that I want to create, what we want to do is basically have all of these nodes running at the same time, sending requests to each other, and then responding with the data based on whether or not the data is realistic, straightforward, if the code validates. So next time I'm going to be taking this code and we're going to be stepping it up a notch. We're going to be talking about concurrency. We're going to be talking about some much bigger concepts in programming. But for now, it is so hot in here because the air conditioner isn't working. It's so hot that my laptop literally melted to death yesterday. It was quite the fucking nightmare. And I'm gonna go open up some doors, turn on some fans, and relax. But tomorrow morning, we are going to be spending some time turning this single threaded web server into a multi-threaded web server. And with time, we're gonna start seeing just how this code evolves to become the API front end, the way that the nodes communicate with each other on our blockchain network. Until then, I love you all. You are absolutely wonderful. Thank you for showing up. Remember to like, comment, subscribe, share it on the social networks, all of those things, and I will catch you next time.